Welcome to Webinar Wednesday. On behalf of the Powder Coating Institute, thank you for joining us for today's webinar, Best Cost Reduction Hacks Hiding in Your Pretreatment Process, presented by Jeff Blaine with Circle Prosco Incorporated. Before we get started, I would like to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them into the questions panel. The speakers will address the questions at the end of the webinar. If we run out of time, there will be contact information on the closing slide that you can submit in to us, and we will email them back to you. This webinar is being recorded and will be available through the PCI store within 2 business days. All attendees will receive a brief survey at the completion of the webinar. Please take a few moments to reply. We appreciate your feedback as PCI continues to develop new programs to offer the topics and training you need. Now I'd like to introduce the presenter for today's webinar. Jeff is the regional manager at Circle Prosco Incorporated. He holds a bachelor's degree in aerospace engineering and a master's degree in business administration from the University of Southern California. Jeff has worked for Circle Prosco in China and North America for the past 8 years, with current emphasis on sales and new business development for CPI's pretreatment and passivation technologies. He is a resource manufacturing nut that loves to meet new people, learn about their processes, and develop creative solutions to move them forward. His kids call him MacGyver for a reason. And as you can see, it's not about the mullet. Jeff, take it away.
All right, sorry you had to read that. Well, hey, I'm just really grateful for this opportunity to speak. I thank PCI and glad you all are here with me today. And I just want to kind of set the stage for a second. The idea behind this talk is to kind of help us all out. We're all facing inflation and have been. We're trying to do more with less. And the idea here was to come up with a presentation that would break down the pre-treatment process into all its various inputs, and then try to uncover ways that users could go out in their process with their existing equipment and find savings hacks that you could implement easily or right now with your existing system. So, you know, for those of you that have been around the trades for a while, there's stuff that I'm sure that you'll see here you're familiar with, you've put into practice. For those of you that are newer, maybe it'll all be new to you. But the hope is that everybody will find something that will be practical and useful and easy to implement, you know, right away. So looking at the pretreatment process, so this overview is we're going to look at chemistry and how you might save in the chemistry area, the water area, how you use energy, and then we'll look a little bit about your management processes, how you handle maintenance, your quality system, and overall we'll take a little bit of a look at throughput and labor utilization. Looking at chemistry, we're gonna look at everything from concentrations and coverage, mechanical action that you have, how you manage the chemical adds, how you control the chemistry once it's in your process, those sorts of things. And then we'll look at ways that you're going to reduce the amount of chemistry you use, reuse chemistry, recycle, that sort of thing, and finally look at filtering. So as we look at chemical application, and you look at concentration, you're going to hear me say this many times throughout the presentation, you're really going to want to lean on your supplier. So in this case, your chemical supplier, and you're going to want to get them to come in and look at your soil load, what kind of substrates you're running through your line. If you're a job shop, you've got a ton of different substrates, you're getting from a ton of different suppliers, and you've got all kinds of different oils and lubricants and other things coming in on your parts. You're going to want your pretreatment supplier to really understand what those are, and then to help you develop the right set of chemistry and the control parameters for your chemistry. So temperature, time in stage, concentration, and to really help you dial that in. And so you don't want to be running too high of a concentration, because we all know parts drag out chemistry, and the higher that concentration, the more chemistry that you're wasting. So again, you're going to want to lean on your vendors to dial in your concentration. The next thing we want to look at, once that's dialed in, is how you're using the chemistry, where you're putting it. So as parts go through your washer, you're going to want to make sure that you've got a good part density in there. We never really want to be spraying just in the air, because if you think about it, you've got evaporation, you've got overspray going out of your stage, and you're just spraying into the air, and you're wasting energy with your pumps and that sort of thing, recirculating chemistry that's not hitting parts. So you want to maximize the part density. You want to ensure all your parts are in the window. What do I mean by that? If you have parts going through and your nozzle are aligned such that you're not getting good coverage on all your parts, then you'll get an operator at the other end that'll say, I've got a problem. They'll troubleshoot and they'll say, this isn't getting clean enough. I'm not getting good coverage on my conversion coating, and they may up your concentration in a troubleshooting move when really it's just you've got blocked nozzles, or you've got misalignment, or you just got parts hanging outside of your spray window. Another thing that comes to that you want to look at, and we'll get into it a little bit more later, is no shadowing. You don't want parts to be blocking other parts when it's line of sight from the spray nozzles into the part itself, because you don't want that chemistry to get blocked. You want good coverage on every part. Let's talk about mechanical action for a minute, and we'll talk about this more when we get into nozzles, but you want to make sure you get good impingement. So just like when you're washing dishes at home, you use that spray nozzle on high pressure, that mechanical action is going to do a lot of initial cleaning work for you to kind of help the chemistry. So you're not running an artificially high concentration of chemistry to get soil off that you could be partially attacking with good mechanical action of that water pressure hitting the part. If you have an immersion system, you still want to think about mechanical action in the form of agitation. You want to be moving parts in the tank, or you want the parts to be agitated, or the chemistry to be agitated in there. So again, you maximize that mechanical action. Let's talk about chemical management for a minute. So in these three boxes that are on the slide, these are three different ways that systems are typically controlled for chemical adds. So there's manual over the side adds. So that's the lowest tech operators just adding on a fixed schedule. And what happens here, if you can imagine it, if you're putting parts through at a steady rate, the operator adds at the beginning of the shift, your concentrations are going to be really high, and you're going to start consuming that chemistry, and the concentration is going to go high, and it's going to go lower and lower as it gets consumed, as it gets drug out. And then at some point later in the day, hopefully on schedule, they add it again, and the concentration has gone down, and then it's going to surge back up again. So what happens is you have times of the day where you're at a really high concentration, an extra high concentration, and if you think about it, during that time when your parts are dragging out chemistry into the rinse stages, you're really dragging out a high concentration mixture, so you're wasting chemistry. So then you get into fixed rate dosing pumps. So now you don't have the operator adding it, you have a pump that's putting it in a fixed rate. If you're running the same parts every day with the same soil load and you never have line stoppages, then your concentration can be fine-tuned and it stays fairly close to what you want it to be throughout the production run. But that's not real world. So again, a fixed rate dosing pump is better because maybe it won't forget to dose like the operator might, and you can tune your add of chemical more tightly to your production, so you're keeping that concentration in a tighter window. But you got to worry about, like, hey, make sure that the pump's turned on, the chemical drum doesn't run dry, and that sort of thing. But finally, you have something that's kind of like cruise control in your car, right? Automated sensor activated dosing. That's a mouthful, but all it means is you have a control system where your pumps are triggered to go on and off based on a sensor input that you have. So it might be in your cleaner stage, it might be conductivity. For some pretreatment suppliers, your pretreatment might be also conductivity, or it might be pH or some other factor. But the bottom line is you have the right probe that your chemical supplier has told you, and it indicates to a controller, this is where I'm at conductivity or pH. And then the controller knows when I go below a certain control limit or above a certain control limit, I'm supposed to do something. I'm supposed to add, I'm supposed to shut off. But the bottom line is what it does is it really allows you to match your chemical concentration and keep it in a tight range and match it with production demand. So these are some things you want to think about. It's a low tech versus high tech investment, but you really want to keep your chemical concentration in the range that it needs to be and not a whole lot more, because we know there's things happen, you get drag out that's going to take things out of the stage. All right, you'll see this diagram when we talk about rinsing again, but basically this is getting into reduce, reuse, recycle, so conservation techniques. So you're paying for chemistry, and we know that the parts, on this diagram, the parts are moving from left to right, and you can see arrows going from right to left, from rinse stages back into chemistry stages. And then you see fresh water coming from the top there in the white box. So the whole idea of counterflow is you're going to take the rinse that follows a chemistry stage, and instead of adding fresh water as makeup water in the chemistry stage, you're going to use water from the subsequent rinse tank to come back into the chemistry stage. So if you look at the diagram in the far right, rinse 3 is going back into the chemistry stage. If you look at the middle, rinse 2 is going back into that chemistry stage. This is just an example to show you that as the parts carry out chemistry from the chemistry stage into the rinse that follows it, if you take rinse water and you backflow it to make up the chemistry stage, you're recovering some of that lost chemistry, and that's exactly what we're trying to do. And the other thing is, when you're adding fresh water, a good way to add fresh water is to do it in a misting riser that's in the stage. So rather than just pumping it into the tank where it's going to mix with the chemistry that's got soil and other things in it, you can add it through a misting riser. And you can also do this when you counterflow the stages. So the idea is the most pure water coming into a stage for makeup water, let it hit the parts first, and then let it fall down into the stage rather than going into the stage directly and mixing. You get the maximum benefit from that clean, pure water, and in this case, water with some chemistry in it. A couple other things I want to say here. We're seeing a lot of people, when they're putting in systems, or if they have space on older systems, using a pre-clean stage or a knockdown rinse. And you'll see that on the far left of this diagram. And basically the idea here is you're knocking off debris, you're using that mechanical action with water to go after and soften up soils on the parts, and to have just really excessive soils come off and not contaminate your cleaning stage. So there's less work to do when it gets in the cleaner stage. And you can see in this diagram, we have rinse number 1, which is after the cleaner, backflowing into both the pre-clean and the cleaner stage. And the idea is you'll get a little bit of that residual cleaner that's drug out into the rinse to go into the pre-clean stage, so it begins to wash the parts early, and that just keeps your bath life on your cleaner longer. And finally, another thing I'll say, just from simple controls, it's always a good idea to have some kind of photo eye or something that can shut your stages off, so you're not running pumps needlessly when parts aren't running through, so that you're not wasting chemistry and overspray and evaporation on heated stages, and you're also not wasting energy to run the pumps and that sort of thing. All right, so moving on, we'll look at chemical management and maximizing bath life. So you want to filter the bad stuff out. Couple ways to do this. You can use, if you have cleaners that are formulated to split the oil to the top, then you can use skimmers. There's a couple examples, belt skimmers, disc skimmers, that are shown there to kind of accumulate the oil and pull them off. If your cleaner emulsifies the oil, basically spreads it out throughout the bath, then you can use bag filters to get that out, to preserve and maximize your bath life. One trick that I've seen that works really well is you take a bag filter and you wrap up some strong magnets and you put it down into another bag filter and you let it pull out, things like metal fines, blast media, and things like that as it goes through the filter. And then when you're done, you just pull it out, unwrap that magnet, and all the fines are trapped there, and you can get rid of it. So those are some things on filtering to maximize the bath life. All right. So we're going to move on to water. There's a lot of similarities between the water and the chemistry because if you're saving water, the baths are diluted, right? You're not using concentrated chemistry. So if you're wasting chemistry, you're also wasting water. So a lot of these things are the same, so we'll go through them quickly. Here's the diagram again. I just want to say very quickly, as we said before, the idea of counterflow, if you have a line that has multiple rinses, which a lot of times we see if you're converting from a zinc phosphate or an iron phosphate to a zirconium that uses less stages, you might have extra stages that you use as extra rinses, or you may have already had them built into your process because they required them, and you're just deciding, I'm going to keep those stages running and I'll just have multiple rinses. You can also counterflow from the cleanest rinse to the dirtier rinse and so on, and the idea is the same. You're just reusing that water as many times as possible before you're counterflowing it to the drain, and you're minimizing the fresh water add that you need to put in. And again, just stressing that freshwater halo or the makeup water halo in a stage to utilize that first input of water to hit the parts when it's at its freshest. All right. Okay, when it comes to water management, you know, you want to go ahead and use good filtration here again. And the filtration methods are the same as I just said. So you're filtering your rinses with a bag filter or a skimmer if you need to. I show my little R2D2 thing here for the Star Wars fans. It's a shop vac. It can be very low tech. I've been in lines that are very small. They're kind of Frankenstein together, and the oil will accumulate in a corner where the tank kind of eddies, and the guys just take a shop vac and they suck the oil right off the top. So you can, like I said, the idea is you can begin saving right now. You can begin solving headaches right now, and it doesn't have to be a high-tech solution. I think the other thing, it may go without saying, but it's important to stress that, you know, you really want to look at balancing the overflow rates in your stages, like you're overflowing your rinse water, so you're putting in fresh, or you're counterflowing, but you're taking that dirty water and it's going to drain, right? So you're overflowing. You want to make sure you dial that in, and you're balancing the effectiveness of your chemistry stages or your rinse stages to do the job they're meant to do, to clean the parts, to get them rinsed, to coat the parts. You want to balance the amount of counterflow that it takes to kind of preserve the cleanliness and the purity of those baths at a level where they'll do their job, but not go overkill where you're just running too much water down the drain. And again, the counterflowing between stages will help that, but you want to really look at your overflow rates as well. And that obviously is going to depend on your soil load and other things that you're facing. And again, it's important that you rely on your suppliers to really help you. Get your chemical supplier in there to help you really look at these things and dial them in. Okay, I'm going to go back to part presentation again for a minute. You want to make sure that you're getting good. You're letting your nozzles do the work. So you want to make sure that your parts are hung in a dense fashion, that all the parts are in the spray window. There's no shadowing. But the other thing to mention here is that you really want to look at how you're hanging your parts to maximize drainage, so that you're minimizing drag out. All right. Here's a little bit, we've been talking about nozzles a couple times, so I want to talk about alignment in different types. So if you look at the bottom right, there's a lot of different nozzles. There's more nozzles than you probably know what to do with. So the most common types people use are flat fan nozzles or cone nozzles. And really, if you think about it, if you think about the flat fan nozzle is when you're washing down your driveway and you're kind of putting your finger over the end of the hose and you get that fan pattern. You're trying to increase the pressure. You're trying to maximize impingement on the part and maximize that mechanical action across a fan. When you have those, if you look at the diagram at the top right, it's a top-down view of a washer, and the red arrows going from top to bottom are parts flowing through the washer, and it's showing that these fan nozzles are kind of angled at a raked angle so that they're kind of washing across the parts as they go through. and you kind of use the action of the parts moving past to give more mechanical action as well. Sometimes cone nozzles are used to kind of spread out, have less direct impact. Sometimes if you're trying to lay down a zinc phosphate or something with the crystal structure, you might want to have less impingement and a more gradual flooding kind of thing to let the crystals set up and things like that. I'm not an expert on zinc phos. We try to help people get out of zinc phos, but I do know that those are the common nozzle types. But the idea with your nozzles is this: for cleaning action and for conversion coating, you're trying to maximize that impingement to get the part clean and use that mechanical action, and you're trying to get complete coverage across the part so your coatings can do the job that they're supposed to do. All right. When it comes to pressures, different people have different rules of thumb, but the thing you're always trying to balance is you want to maximize your pressure for impingement, but you want to keep it low enough you're not blasting small parts into the washer. So again, you have to find your balance there. All right, let's move on to energy and look at how you design your system, how you manage your system, the maintenance you do, and we'll talk briefly on how chemistry relates. So one thing that's out there, if you look to the far right, it's just a picture of a generic VFD drive, a variable frequency drive for motors, and then below it you'll see like what I call a throttle valve on a line going to riser stacks in a washer. So sometimes systems are set up where they don't have VFD drives, and so you're kind of set with a pump banging away at the system, and if you want to change the pressure on your risers, you kind of hit these throttle valves, and so what you have is a pump working all the time hard, giving max delivery of flow, and you're throttling it back with these gated valves, and it's just banging against it, and so you're overworking your pump for what you need. So ideally, if you can put VFDs on there, then you can control that flow, and you can control the pressure that you have, and you can use gates just to fine tune things between different risers as you need to balance pressure, but it minimizes the work that your pump needs to do. The other thing that you can look at is if you're a job shop and you run really big parts and really small parts, and you want to shut off some of the verticality of your washer, meaning your parts are just going to run through a window, you're not going to hang them such that they cover the whole altitude of your washer. You could consider, if you're putting in a system and you know that's what you're going to do, you could put your risers in zones so you have high and low, so you're not using all the risers and pumping more water than you need to and heating more water than you need to, etc. And then again, using sensors to shut things off when you don't need them is kind of a quick thing you can do to save. When it gets down to management practices, again, leaning on the trades, you want to work with your chemical supplier to optimize your operating temperatures and your concentrations for your soil load. And I will say this: it's really important you work with your steel vendors and your aluminum vendors, substrate vendors, to really work with them to not have excessively nasty soils on the parts whenever you can. And we'll talk about this later, but it's really important to get them to agree in your quality agreements with them to not change things without letting you know, so you're not chasing your tail. I know, easier said than done, but it's important to work with your suppliers to try to streamline your system. It helps you reduce costs if you're not going after really pernicious soils when you don't have to be. And then the last point I'll make, and again, job shops are really great at this, sometimes captive shops less so. Job shops have to survive running anything and everything, and so they get really good at figuring out how to batch orders and keep like things together whenever they can. But it comes down to, when you're setting up your system, you really want to look at those special cases, the really nasty soils, and you want to find a way to deal with them separately, so that you're not setting up your whole system with really high concentrations of chemistry, running at really high temperatures needed for that worst case scenario on all your parts. Otherwise, you're just throwing away money on your typical runs. So you may want to look at pre-cleaning. Sometimes I've seen shops pre-soak really bad parts ahead of time to really go after the soils. You're just going to have to look at the overall cost trade-off between labor, Do you want to hit it if you've got a wash bay, a manual wash bay? Do you want to hit it in there first before you hang it on your conveyorized line, so your conveyorized line can run at a setting that works for most parts, not these really nasty ones? You get the picture. So you're going to really want to look at where your cost structures are, and you're gonna want to see what costs you money, and then you begin to make compromises. And again, you guys that have been in business, you know this is what you're doing. But these are some ideas of pre-soaking parts, or handling them offline for nasty things, so you can tailor your system for the normal case, if you will. The other thing on maintenance, having a preventative maintenance schedule that you follow is critical. I mean, we've been in lines that are pristine and they have a lot of flexibility when problems come. They're not chasing down the obvious things, and their operators can really quickly dial in on what's going wrong, instead of looking at lines like, oh, it's leaking here, this pump's not working right, whatever. And one of the issues that comes into energy is descaling burners on a regular basis. Making sure you keep those clean so that you're not, again, wasting a bunch of natural gas to heat burners that aren't getting to your chemistry. You know, it's fighting itself. And then obviously you want to be on a schedule to routinely clean out your risers and your nozzles, removing that sludge so they're not blocked or plugged. And then training your operators to do that in the right way. We've seen operators poking hard things into nozzles where it's plugged from the backside, they're poking from the outside, it just goes in and comes back and clogs, and in the meanwhile they kind of booger out the nozzle, and then you're just peeing on your parts instead of getting that distribution you paid money for, if you will. Sorry for being crass there. But anyway, blocked nozzles, misaligned nozzles, broken nozzles, all of these things cost you money and waste energy. One point on chemistry, again, we talked about fine-tuning your temperatures for the typical case, and then having your chemical supplier help you get strategies to minimize chemical use to go after the really gnarly stuff. I mean, you'd be surprised. I've been in factories, we go in and they're just using chemicals like crazy all over the place, because the solution is always, well, up the concentration or add more chemistry, or this over the side ad will help you. And you really need to challenge your chemical supplier to say, that's not always the answer. I need to be able to run my system. You guys give me a set of chemistry and you help me to optimize it, and then help me deal with these special cases in a different way, rather than just kind of, using a nuclear weapon on everything, right? So it wastes money. All right, you want to eliminate the tough soils where possible. We talked about that. And then the last thing you could look at for chemistry, and I won't touch on this, this is not a zirconium presentation, but basically if you're running zinc phos or iron phos, zirconium technology has really developed a lot. All the suppliers have products out there, and they really can help you save energy because they run in less stages. They can run at ambient, so you're not heating them, and they don't produce the sludge that causes these nozzle backups and other things. So it's a lot easier on your operators, a lot easier on your system. And again, you've probably heard more about that than you want to, but this is really where it comes into play. All right. Okay. The other thing we want to look at is maintenance, quality, and throughput. So kind of look at how you and your people are interacting with your system and with your other inputs. So at a system level, I can't stress enough, you will thank yourself if you haven't already gone through with your team and identified the failure modes that happen in your system, whether that be product failure modes, like these are paint failures on my parts, or process failure modes, like I've got clogged nozzles, or the pump went down again, or whatever. If you look at your system and you just do a brainstorming kind of institutional knowledge dump, like what are the things that go wrong, guys and ladies, that on our system, and then start getting that institutional knowledge together to say, well, when this goes wrong, what typically in the past has caused it, and you begin to develop this, you articulate and you document this institutional knowledge. We all know we've been having trouble hiring people. There's a lot of turnover in labor. So having this to where you can quickly bring somebody up to speed is worth its weight in gold. You also want to track your compliance of your people after you train them on these failure modes. You train them on what's required for preventative maintenance. You keep that schedule going and you document it, and you begin to help people see when the preventative maintenance doesn't happen, it triggers some of these failure modes we talked about. Which way do we want to deal about it? When it's calm, or when we've got parts backing up and people screaming and looking at us like, what are we going to do? The other thing is, you want to identify defects that you get in your product, and a system failure that occurs that likely caused that. You're going to want an operator to know what it looks like when they have dirty parts, and have a quick way to troubleshoot that. Oh wow, I'm seeing I've got beading on the parts. There's no water break free. I better go check to see if the cleaner pump is running, or if the drum is dry, or whatever, so that they're not chasing their tail. All right, so specific actions that you want to look at: inspect nozzles and risers, checking for damage, plugged and misaligned. This is something that you should be as a quick check every day. And speaking of every day, you should have daily checklists of a startup checklist, a shutdown checklist, things that people can quickly go through, just to make sure nothing's forgotten. I mean, how many of you have come into the plant and it's full of foam because the heater was off on the cleaner stage, and somebody forgot to turn off the water, and it just overflows, and you got a bubble bath in your entire paint department? Things like that. Checklists kind of save your bacon on that sort of thing. You're going to want to inspect for leaks. Again, you're wasting money if water and chemistry is coming out. It's a cleanup and safety hazard. The descales we already talked about. Tank dump and boil out. You want to have that on a regular frequency, so you're not accumulating a bunch of excess stuff in the tank. Remember, you're gonna have chemistry wasted having a chemical reaction. If you're running zirconium, you're going to want to make sure, for example, that your cleaner is phosphate free, because if it gets drug out in there, that zirconium is going to want to preferentially bond to the phosphate molecules rather than to your parts. So that's one thing to check with your chemical supplier is, hey, if I'm running zirconium, is my cleaner phosphate free? If it's not, they should help you get one, because you're going to waste chemical reaction with it bonding to the cleaner. And then the other thing about creating a robust process and control system is you're going to want to identify control parameters and acceptable ranges with your chemical supplier on where things should run, and have them give you a reaction plan that they recommend. What should your operators do when it goes out on the high side or the low side? You're going to train people and on those control procedures, and then you're going to have some kind of record of the checks that they're monitoring, and keep those for troubleshooting as troubleshooting tools. You want to maintain your records of critical parameters, so you're going to want to know what your usage is. You're going to want to see, how much chemistry do I typically use? What temperatures am I typically running at? Especially if you're in a place where the weather swings a lot, you're gonna build institutional knowledge about how things run when it's cold, when it's humid, when it's hot. These are good things to kind of document, so that, again, as you're bringing new people in, people don't get caught unawares. I think this point about checklists I already made, but the next one is implementing quality agreements with suppliers, requiring advanced change notification if they change things. And again, I know it's easier said than done. They'll just blame their upstream supplier or whatever, but the idea is to get people thinking about, you expect to know what you're getting and when that changes, and so that you're not getting thrown off on some new soil that's killing you. We had a customer that was having pinholes and fish eyes. They couldn't figure out what was going on, and it finally came out to be like, it was cold outside and the guys were putting waterproofing on their boots, and then they were bringing that into the plant, and that had silicone in it, and it was getting into the system. So you'd be amazed. I got all kinds of funny war stories about that stuff, but you're going to want to train your employees to think about any kind of soils that are coming in, WD-40, boot dressing, perfumes, lotions, things like that. That sort of thing all matters, and it's not even going through your system. It's the sneaky stuff. All right, and then you want to implement traceability once it's in-house, meaning you know what lot of chemicals went into your wash line when you were running what parts. And again, it just helps you on quarantining something. Your customer calls and says the paint's sheeting off of these tractor parts that you sent me. What's going on? You're going to want to be able to tell them very quickly, hey, let's put this amount of things on hold, not like, geez, I don't know when it stopped and started, and then they're putting everything on hold and you've got a big claim on your hands. So traceability is really important. All right, looking at labor and throughput for a minute, you're going to want to look at how everything moves through your system, how the process flows. You're going to want to look how materials flow through the process, how parts flow through, how people flow through each step of the stage. And you're looking for delays and stoppages. So this is just Lean Manufacturing 101. You may have heard spaghetti diagrams. You're going to really want to map out how everything's moving, and you're looking for ways where there's excessive or awkward handling, there's waiting, there's wasted space. You know, sometimes you'll look at your process and you're, geez, why do I always get flash rust right here? Well, it's probably because it's between stages and your parts are drying down, and you know, what am I going to do to fix it? Again, I've seen people fix it by adding over the side ads and chemicals, and as a chemical supplier, I should be happy about that. But really, that doesn't have to be the way to fix it. I mean, you could put misting risers in to keep the parts from drying down. Yeah, it's just stuff like that you're going to want to look at. Design part hanging recipes. I'm a big fan of visual management. So if you have recurring parts coming through, it's nice to give a visual aid for the people at the load station, like almost like a shadow diagram that shows the rack that it's going to go on, or the hangers it's going to go on, and which hangers and how the parts are to be hung. So again, you maximize that part density going through, you minimize the amount of wasted motion and labor, you know, load that you need to load the parts, so they get real high efficiency load and unload. And then you're designing it for part density going through. Sometimes there's a trade-off. Sometimes you might have a light part density because of your labor situation and you need to load it more sparsely. I get it, but you want to consider these things. Where are my costs? Are you really got to understand your cost inputs in your business? And where they come from, and you really want to train your paint department people to understand the cost that they own, so that your supervisors and your leads and your operators can make good decisions and come up with best practices for how they're doing the jobs that they do day in and day out. All right, the last thing I'll say on this is evaluating racking offline. So maybe you need more throughput for whatever reason, you're running out of capacity, or you want to drive your costs down and you want to speed your lineup. And that does the domino effect, right? Because then your chemical supplier is pulling his hair out going, wait, you need 60 seconds residence time in here. Your stage is 10 feet long and now you're running 20 feet per minute and now you only got 30 seconds in there, timeout. And it causes problems. So the other thing you can look at is you can look at racking offline. You know, are there parts that are complex enough where low density means enough to you in terms of the bottom line that it would make sense for you to have people preloading some rack that you have to hang and put through as a unit. You know, again, it's going to depend on your operation and your constraints, but these are things that you can look at that maybe when you get caught in the battle, you're just used to hanging them as fast as you can and you just throw more bodies at it. But maybe you can do that offline. All right. That's kind of my quick storming through the different inputs and areas that make up a pre-treatment system. I certainly haven't covered everything, but these are meant to be examples in each area: chemistry, water, energy, labor, throughput, your maintenance and management systems. I hope that you found something helpful, and I'd be happy to take your questions. I can't see your questions, so Kevin's going to read them out to me, and I'll try to get us through as many of them as I can.
All right, thanks, Jeff. Yeah, there's a couple of questions that have come in. One, how can blasting and other surface prep positively or negatively affect the cleaning process itself?
Yeah, that's an excellent question. So when we think of blasting, it's really great for going after inorganic soils like rust and scale and other things that you would have to, you know, maybe have to bang away at a high concentration of chemistry or for a long time. So it does have its benefits. What I would recommend, if you're going to blast, if you could get away with a knockoff rinse ahead of time to kind of have that first stage just collect all that grit and debris and blast media that's going to be on the part before it actually gets in your cleaner, that would be great. Some caveats though is if you have really heavy soil on your part, like oils, like organic soils we call it, if you have really greasy or heavy parts, the risk you run with blasting them to get that off is the blast media can actually impregnate the soil and drive it deeper into the part. So as that blast media is creating a profile on that part, it's kind of squishing, for lack of a more scientific term, the oils in there, and they can get embedded and then become really difficult for your chemistry to clean off. So what I would recommend is if you're looking at blasting, get your blast guy and get your chemical guy together and come up with a plan for, you know, what's good rules of thumb for you and your guys to make decisions on. Am I going to blast this first, or am I going to pre-clean this? Because those are some things you need to think about. The other thing I'd say about blasting, sometimes people look at blasting, well, why do I need chemical pre-treatment if I'm going to blast? And blast is great about promoting adhesion. It'll give you a profile, but it doesn't do anything for corrosion resistance whatsoever. So if you have low salt spray or corrosion resistance requirements, maybe that's fine. But if you don't, and you need a conversion coating on there, you're going to need to put it on after that blasting. So hopefully that answered some of your question. Yeah.
Yep. In the maintenance section, you were talking about descaling burner tubes and things like that. Is there a means to know when to do that, or to check when descaling is necessary?
I think you're going to see that you're not heating as efficiently as you were in the past. I think the best way to do it is to kind of look at what the, you know, how much scale you're building up over time, and kind of periodically check that, and then build a schedule ahead of that. But normally you're going to begin to see problems with heating, or your gas bill is going to be going up to get the same heating done, that sort of thing. Yeah.
Okay. All right.
You know, and again, it's going to depend on what you're running. I mean, your chemistry and your substrate and kind of what your process is shedding in terms of sludge is going to greatly impact that. So you're going to want to look at what the sludge generators are and the scale generators are in your system. And again, your chemical supplier can help you look at fine tuning your system on a kind of a PM schedule for that. Yeah.
Okay, great. Can you explain what a boil out is?
Yeah, so a boil out is usually what you would have is like an acidic cleaner, and you would give some heat there, and basically it's going after the scale that's on the tank chemically. And what you would do is typically get that to temperature, and then you would be running it through, basically pumping it through your system as if your system was running. And what it's doing is you get good mechanical action. It's going through your risers, it's going through your nozzles, and then it's also in your tank, kind of attacking that stuff. And then when that loosens up, you're draining that out, and then you're shoveling that solid waste out of there, to get that tank surface and all of the piping clean. That's what I mean.
Okay.
It's not a very from a morale standpoint, from a safety and health standpoint, it's something you really want to drive out of your process as much as you can, because it's the dirty job nobody likes. And again, you know, I'm just preconditioned to it. I can't help it. It's a reflex. If you go with zirconium that's not a sludge producing chemistry, it helps really reduce that. I've got a customer right now. They really only use a pressure washer to clean out one stage, and that's their cleaner stage that gets a lot of oil and shot blast media. But their downstream stages, they clean out with a garden hose and they rinse it out. And this is a large industrial system. This is not little mom and pop system. And that's just because they run zirconium and they don't have that sludge buildup in there. It makes a huge difference. Yeah, sorry, go ahead.
All right. Question, Can a primer help in corrosion resistance instead of a chemical wash? For example, blast and then add a primer and then a top coat?
Oh, certainly. Certainly, a primer will help you with your corrosion resistance for sure, especially if you're talking like a zinc-rich primer or something like that. Those are really good at corrosion resistance, sure.
Yeah. For pre-cleaning, what is the minimum pressure required to remove the debris from burned hooks? So I'm assuming it's the dust or whatever that's left on a hook after a burn off.
That's a good question. I'm not really sure on a rule of thumb for the PSI on that. Sorry,
Okay.
but I'll find out. If you keep track of who asked that question, I'll get them an answer before the end of the day.
Okay. For aluminum parts, we run through our regular iron phosphate, and they do not always come out the cleanest. What would you suggest?
So in that case, I'm assuming they're running an iron phos cleaner coater. Yeah. So the thing with aluminum that's probably messing around with your adhesion is any aluminum that sits out is going to develop an oxide layer, aluminum oxide on it, or white rust, sometimes people call it. And so, you know, you kind of got to go after that. You kind of have to go after that and remove that to get good adhesion and get a good surface for the conversion coating to go down on. And again, the iron phos isn't going to lay down a conversion coating on that aluminum either. So again, you can, I've seen people use acid acidulation or deox stages. So they're using an acid to kind of go after that that oxide layer. You can also use higher concentration alkaline-based cleaners to go after that oxide layer. And basically, sometimes you'll hear people talk about deoxidize. You'll hear about it etching the surface, but basically, it's getting to a more active layer of that aluminum to where it can bond with the coating afterwards. If again, zirconium is a good multi-metal. It's a good multi-metal chemistry that will actually build a bond with the it'll lay down a coating on the aluminum, whereas an iron phos won't really do that on an aluminum. So that might be something that you could look at. And there are cleaner coaters out there for zirconium as well. They don't handle as much soil load if you're in a recirculating system as an iron phos cleaner coater would typically. But they are versatile in that way. If you're just wand applying it, if you're just doing a pressure washer, there's great cleaner coaters out there where soil load's not a factor. That would be good multi-metals. They'll get the parts clean and they'll help you with your adhesion as well.
Okay. As far as documentation, what would your suggestion for best practices be? You know, paper, electronic, in the cloud. You know, what's your recommendation on that?
Yeah, I think I think the most important thing is whatever you can sustain. You know, based on your system, based on the people you're working with, whatever you think will stick that you can use, that's the most important thing. Obviously, there's advantages to having electronic records. It's easier to do analysis and things on that. But if you're not doing anything right now, I would say pick the one that you can implement the easiest, that you think your people will continue to do, and then you can always tweak it over time. The important thing is building that muscle, that habit of keeping track of the things, and then really helping people understand why. And the thing I want to stress too is you don't have to understand all the chemistry. You got enough to do to run your business. There's enough things you're being asked to do. So really lean on your suppliers to come in and do training, to train your people to answer their questions in real time, real situations, so you know the whys behind things enough to kind of have some intuition, but you don't have to be the experts on the thing. But I would say whatever you can implement quickly and sustain is the best place to start.
Okay. One more question here is RO versus DI water. Which one is better for halo rinse?
Again, I think what you're looking at with between RO and DI, the level of purity you know, it's a big step when you look at the number, but in practical terms, it's not a huge step. So again, I think I would look at the cost for you to implement the system and sustain the system is probably a bigger driver. I think you could use RO or DI, either one, and get a good, sufficient halo clean rinse at the end. If you're having some kind of purity problems or whatever, we need to dig into your specifics there, but either of those should be sufficient, I would think.
Okay. All right. That was the last of the questions that I had in there. So if you could just advance the slide there, I got just a couple quick announcements and things to remind our audience. First of all, we do have Powder Coated Tough magazine, which is exclusively for the powder coating. It's a free subscription. You know, you can go online at www.powdercoatedtough.com and sign up. You can get it either electronically or in a print edition. Next slide also. And we now have 4 digital editions in Spanish. Those are available also online. You can sign up for either one of them or both of them. So if you have any Spanish-speaking members here in the States, or if you have a company down in Mexico or somewhere else that can use this, it's definitely a free one. Next slide, Jeff. And then in about a week and a half, we have our powder coating week coming up. It's going to be down in Orlando, Florida. Registration is now open. It's just about a week and a half away. Go online at the conference, powdercoating.org. You can take a look at all the things that are going to be talked about, a lot of great papers. In fact, Jeff will be one of our speakers there. So he has another topic he'll be talking about. So
don't let that dissuade you from coming. You can always take another session. You don't have to be fine. Yeah.
All right. And then the last slide there is if there are any remaining questions that come up, feel free to send them to myself at kevin@powdercoating.org. I'll get with Jeff and we'll make sure we get an answer back to you. Otherwise, I want to thank you, Jeff, and I want to thank everybody for attending this webinar. Please watch for the link in the survey that'll come up right after you sign off here and give us some feedback. And thank you and have a great day.
Thanks, everyone.